Okay, let's go to page 9 and let's pick up where we left off. Okay, so we're going to continue with law of signs. Ambiguous case practice. Okay, so number 1 and 2, we're going to draw these triangles all the same way. We're going to get that angle to show up, get the side connected to that angle, and then we're going to draw up the vertical and get that vertical height. Right? That vertical height is going to tell us, allow us to compare what's going to happen with that opposite side A. Okay, so let's recap what we did with number 1 here. We always draw a triangle the same way, especially when we have these circumstances where we have a side, and angle. We call this a non-included angle because it's not between two sides. So 57 degrees, 19 is the side here. We always want to put it in this location just to make it easier for us. We're going to drop the vertical. The vertical is H. It's not part of the triangle, but it will help us decide what's going to happen with this hanging side that is still unknown. So we set up using trig. Sine of 57 is equal to opposite over hypotenuse. Cross multiply, we solve for H, we get H equals 15.93. Now this 15.93 is going to tell us what's going to happen with that 11. This side length is on a hinge, so it's kind of swinging back and forth, and we see that it's never going to land on the opposite side because it's too short. This height is too long. There's no triangle that can be created with such a short side because this angle is set. We can't make this angle any smaller, so that tells us that we have 0 triangles. Okay. We're always going to be comparing the vertical height with the opposite hanging side, and that's going to tell us whether it has a chance of making 0 triangle, 1 triangle, or 2 triangles. Okay. Number 2, we had our angle 30 degrees, side 26. We drop our vertical. We go through SOHCAHTOA. We solve for H. H equals 13. Now H equals 13, and the A value is also 13. So that means this side, the only time it's going to hit this opposite side is right here when it lands as a right angle. So that tells us that not only can we create 1 triangle, the only triangle that can be created is a right triangle. Okay. Everybody okay with that? All right, so moving on to number 3. We haven't seen an obtuse triangle yet, but I think this will be easy just for us to, I think we'll be able to tell just by looking at our triangle here. So same step, let's just create an angle that is greater than 90 degrees. Side B is 18. And side A is 12. All right. Is there a chance for this to connect to the opposite side to create a triangle? Too short, right? This is too short. So here we say that this is 0 triangle. Now, if you had to guess, what do you think the condition is for this to be a triangle? How long does this have to be? Actually, here we don't have to draw. We don't have to figure out a vertical. Okay, so there's only one number we have to compare, and that's with this 18, right? So as long as what? Yeah, as long as it's greater than 18, it's going to be create a triangle. Now, if it's like 18.1, it just means it's going to be a really, really small triangle, but it's still enough to get that triangle. What if this was 18? Still wouldn't be, right? I mean, it'll get to this length, but it's not going to be connected to any part of the side here. Okay, so 0 triangles here. Okay, try number 4. That's right. Yeah. So if you have an obtuse triangle, you're never going to have an ambiguous case. It's always going to be 0 or 1. We're never going to deal with 2 triangle. The only time we have 2 triangle situation is if your hanging side is between the vertical height and the side next to it. Okay. So let's try number 4. Okay, number 4, what's different about number 4 here? Yeah, they give you 2 angles. So if they give you 2 angles, then you're always going to have 1 triangle. You're never going to have to worry about an ambiguous case. So if we just draw the triangle, we can see that, okay, there's no decision for us to make. We know it's going to have to be 1 triangle. Okay. There's no hanging side here. These 2 angles kind of sets this triangle up to be just 1. Okay, so right now we're not going to be solving. We'll do that on the back page, but right now, just the first page, we just want to set it up and just determine, is it 0 triangle, 1, or 2 triangles? Yes?
Why is the 17 on the left?
I had my angle A, let's see, angle C, angle A, angle B. So you can draw your triangle any way you want to. I just drew it this orientation. But essentially, if you have 2 angles, you're always going to be sitting at 1 triangle. All right, number 5. Let's see what happens with number 5. Okay, first things first, right? Drop that vertical altitude. And see what we can conclude based off of that height. Cross multiply, 32 sine 37. Okay, what's h equal to? Okay. Okay. All right, what do you guys notice here? 2 triangles, right? You see that A equals 27, that hanging side is greater than the height, so that means it's going to be able to hang out here. But it's also shorter than 32, where it's going to be able to hang out here as well. So there's 2 possible triangles because this hanging side is smaller than 32, but greater than 19. Okay, so the next page, we're going to focus on solving for these 2 triangles. But right now, We just want to get that first step down and be able to recognize what type of situation we're dealing with. Okay. Any questions there? All right, number 6. Okay, what do we find for H? 51. Okay, 0, 1, or 2 triangles? 2 triangles, yeah. That 55 is hanging out between the 51 and 57. That's going to give it that ambiguous case there where it could swing out as an acute triangle or swing in as an obtuse triangle. Any questions there? Okay, next page. Okay, so now after we discover whether it's 0, 1, or 2 triangles, if it's 1 or 2 triangles, we're going to find all the missing sides and angles. We're going to solve the triangle. Okay, so number 1. Get that vertical height for reference. H equals 10. All right, what can we conclude? Yeah, has to be a right triangle, right? That C equals 10. The only chance that it's going to be able to link up with the other side is if it's right here, right? Any other location is going to be too short. So it's going to have to land right at that height, at that vertical, forming a perpendicular angle. So it's going to be the only way we're going to deal with it, have a triangle, is if it's a right triangle. So we can say this is guaranteed to be only one triangle, and it has to be a right triangle. Okay, so we're going to solve this right triangle here. Oops, sorry, angle C. Okay, it's a right triangle, so you can use Pythagorean theorem to find that missing side, or you can use special right. This is 30, 60, 90 triangle, so the long leg is going to be √3 times longer than the short leg. Either way. Okay, we're going to create room for number 2. Any questions with 1? Okay, let's see what happens with number 2 here. Let's find that h. That's going to allow us to know how to interpret that 32 there. Okay, h equals all right, compare those values there. What does this tell us? 2 triangles, right? 2 triangles. Okay, so we have 1 triangle here, another triangle. So we got an obtuse triangle, and also we have a Q triangle. Okay, let's do the more obvious one first. Let's do the larger triangle. So I'm going to put this to the side here. This is triangle 1. Label all my parts here. Okay, so we actually have enough information to find angle B because we use law of sines, right? We have a perfect pairing for A. We have all the information from A. We can solve for B. Once we solve for B, we can figure out the rest. Okay. So B over sine of B is equal to A over sine of A. Okay, cross multiply, try to get sine B by itself. Divide both sides by 32. Okay, plug in a calculator. We're going to have to rely on inverse trig here. I do want to point out something about the accuracy of your angle. So here's a way for us to improve the accuracy of our answer. Okay, so you're going to enter that 38 over sine 47 in your calculator. Again, make sure you're in degree mode. Now, that's a decimal value that's more than 3 places, right? So rather than doing to 3 decimal places, because we're still in our intermediate stage of our problem, we want to try to hold on to these values as much as possible. But I don't want you to have to worry about having to type all this in. So to make it easier on ourselves here, we'll do this. We'll do inverse sine. So if you just hit sine twice, rather than typing all that in, if you do second answer, it'll put in all those values for you. So do second negative, bottom here, second ANS. And that will just insert all that value for you, and you'll really get as accurate of a degree measure as possible. And then from there, you can round it down to round to 3 decimal places. All right, it does make a difference going out to the 4th and 5th decimal place, especially at our intermediate stage. So 60.283. So that's how we can gain accuracy if we just use second sign or inverse sign of the answer so that we can have all that intermediate decimal value inserted in. 60.283, yes. Say it again. Yeah, for C, I think it's okay. You can just use 0.283 and just use that. Yeah, you don't have to. You can use that second answer again if you like. I think this is where our answers can really differ if we don't if we don't have enough accuracy. So this is where I think it's more important. Okay, so angle B is 60 point. Okay, so now it becomes a little bit easier. Subtract from 180 to get that 72.717 degree. And now the final step for this triangle is to find that missing side. And now it's just going to feel like what you did on the quiz, where you set up law of sines and you just trying to find a missing side. Okay, I'll put that over here. C over sine of 40. Oops, C over sine of 72. Shift that sign of 72.717 over to the right side. Solve for C. You get 41.791. Get a different answer. Let's see. Oh, 4. Sorry, not 41, my bad. 4.178, sorry. Okay, you guys get that? Okay, so we have one triangle down. Now the other triangle is going to be the obtuse triangle here. Yes, question? Really? Let me see. 3.2. Oh, sorry, 32, my bad. Okay, 41 points. Sorry. Okay, sorry, 41.778. Yeah, you can either round that last number or you can keep it. Okay, so now I want us to just kind of revisit the idea that the triangle that we just found is out here, but then the new triangle that we're going to find is going to be an obtuse triangle here. But then there's a special relationship here, and that is with isosceles right triangle property. Okay, this is 32. We're kind of just using this imaginary triangle here to indicate that this 60.283 is going to be helpful to find an angle that we need. Because if this is 60.283, then this angle is also 60.283. And if that angle is 60.283, we know that the obtuse triangle is going to be 180 minus that angle. Yes, question? Oh, you mean how is this 32? Because the height is 27.79, but 32 is between 27 and 38, so it's going to be able to land nicely somewhere in this region. So we're able to create this obtuse triangle here. So basically the relationship that I want to show you is that this angle is going to be related to this angle here. These angles will be supplementary angles to each other. So if we know that this angle is 60.283, then we know that this obtuse angle there must be 180 minus 60.283 because we have that isosceles triangle relationship. Okay, so here's the second triangle. I'm going to carry over a lot of information from the first triangle here. Angle A is still 47. This is now angle B, and this is angle C. 38 is still here. 32 is this hanging side. And then this angle here, 180 minus 60.283 is what? 119, yeah. So the reason why this is easier is because we now have two angles. And if I can just find that third missing angle and then use law of sines to find that missing side there. Okay, so 180 minus 47 minus 119 will get us that angle. And now finally, law of sines will help us get to side C. Okay, any questions with number 2? Okay, yes. Okay. Oh, you don't understand this angle here? So are you okay with this 60.283?
Yes.
Okay. Now, this angle is going to be the same as this angle here. Because we kind of created a isosceles triangle. So if this imaginary triangle has 60.283, yes. Right, right. Okay, so let me back up a little bit here. Okay, let me back up a little bit here. We have this triangle here. I'm sorry, let me see. Okay, we started off with 47 degrees. Okay, we found this vertical height, and then we realized that it was short enough to allow this hanging side to kind of swing back and forth. So this swinging side could either be here or it could be here. Okay, are you good with that? Okay, so we found this angle here, didn't we?
Yes.
This angle is, yeah.
60.283.
Okay, now this hanging side is both 32. Okay.
Oh, I see it now.
Okay. This angle is also 60.283. And this is basically, I want to show you that we can use this information to help us find the angle that we really want, which is this obtuse angle. This is a linear pair. Subtract 180 from 60.283, and we can get this angle. We don't have to draw this every time, but I just want to show you that once you find this angle, you can always subtract from 180 to get to the angle that you really want for your second triangle, which is 180 minus 60.283. Okay, does that make sense?
Yes.
Okay, so let's try number 3. Okay, what do you notice about number 3 that's different than before? Obtuse, right? Obtuse triangle. Okay, is this opposite side long enough to make a triangle?
Yes.
Yeah, 60.5 is more than, as long as it's more than 10.1, it's going to be able to extend. Okay, we can jump directly into law of sines to find our missing angle C. We can see that there's a pairing here, A and sine A is we can use that to help us find angle C across from 10.1. Okay, cross multiply. We're just, I think we're gonna be able to get it done in class. We're just gonna get through number 5. That's it. Okay. Okay. So for C, inverse sine Okay, so now once you find that angle C, we can work backwards. We can find that angle B. Subtract from 180. Yep. And now our final step, use law of sines to find that opposite missing side B. Yes. Okay, go ahead. Cross multiply, get B by itself. Yes, question? Oh, yeah, so this should be, I can make this 7.434.
How did you get 4 in decimal?
Yeah.
So rather than 3.
Oh, hold on. Yeah. Let me try again.
Took it off into my head. I mean, I was close to It was so confusing. Congratulations.
So you guys get a different decimal than this? You got 432. Okay, let me see.
It's like breathing.
You got 16. I got 16. I think it's 16.
Yeah,
I just got
Yeah, I got to that.
Oh, okay, 6.3. Okay, I think that, okay, so that threw off some of the calculations there. Okay, 0.432.
Yeah.
Okay, number 4. What's nice about number 4 here? Yeah, 2 angles, so it's going to just be 1 triangle, and we can jump directly into a law of sines. So this feels just like the check-in quiz, because you can find that third angle and then use law of sines twice to find A and B. Now I'm saying this problem is just like the check-in quiz from yesterday. Good.
Yeah.
Okay, number 5 is our last problem. Number 5. Okay, let's set up number 5. Yes. So tomorrow we'll cover that last topic of law of cosines, and then we'll have next Thursday to review and Friday quiz.
No.
Okay, number 5, our last problem here. Okay, so let's create our triangle. Okay, find that height. Okay, so H is 10.176. What can we conclude about this hanging side here? 2. Yeah, it's between the heights and this known side here. Okay, so let's just focus on trying to get this the large triangle first. Okay, so law of sines. Let's find angle C first. Wait, angle B? You mean angle A? Yeah, angle A, we don't have enough information, so we're kind of forced to have to use angle C and angle B here. Let me start 12 here. Okay, cross multiply.
Yeah.
Okay, 67.689 degrees. Now that you have 2 angles, you can find that missing angle A. And now we can do law of sines again to find that missing side A. Okay, so we have the first triangle. Now the second triangle is just going to be, all you need to do is 180 minus this, and that'll get you your obtuse angle. So 180 minus 67.689, what's that angle measure there? Okay. We have two angles. We can find that third angle by subtracting from 180 as well. And now we're one side away. So we have side A that we're looking for. Now law of sines.
I don't know.
Is it just the recreation? I will like, if I don't know much about that.
Yeah, I know the equation.
Yeah, I know how to give it something, but now that I know that, now that I know it just substituted, it's like, it's just what?
Yeah, I'm just like, how? It's just like, dude, give me
Yeah, I can do this. No.
I don't need
That's, I do anything. You ask Dr. Snow.
That's true. It's just like you should. It's difficult. But that's like, can I do it? It's just like I do mine. I don't know, like, I just don't know. Why do I laugh at it? It's like, it's like, hey,
I have to wear my own shirt.
why? Is it like that?
I don't know, I've never seen that. What? Oh, I hate stupid one-step equation. They suck. They were like, oh, that's easy. Figure out stupid cosine tangent.
I know, I just feel like we've gotten back to cosine scale.
I wish I could figure this out. Looking back.
In the moment, oh my god.
Looking
What if it's weird?
I don't know how I had it.
back on it.
Look at how I found But I'm just saying, I
Students who write bus 4-8 will now write bus 4902. Students who write bus 4531 will now write bus 4887. Students who write bus 4091 will now write bus 4133. Students who ride bus 4261 will now ride bus 4038. Have a good afternoon, Eagle.
it's okay. I was trying to No, I still do. When I first got sick, it hurt so bad. I didn't have to like
Oh my god, no, we're not done.
I guess I'm like 4 questions.
No, I guess I'm like half.
It's both like 2 minutes left. I was just
No,
like
no.
circling all my
Like,
answers.
we could go to
That was like a long
10 minutes left or something. She's like, oh, we have 2 minutes left. Like,
Yeah, we'll put on a 2-minute order.
that was fun.
I did all the content clues and then like I don't know and then when I started reading It was like, I think I messed up. I felt like the negative, I was like,
Yeah, that was so
like,
like, and it's just like, yeah, I would fail this. I didn't even, I didn't even know. Yeah, I didn't really.
it was like an image, it was like 4 black images.
Yeah.
I did like,
I always do the jump.
Sorry, yeah.
this angle is always like, this angle, like, always 5 days.
That's it.
I like how they do that.
Thank you. All right.